Welcome to SciShow Tangents, the lightly competitive science knowledge showcase. I'm your host, Hank Green, and joining me this week, as always, is science expert Sari Riley.
Hello.
And our resident everyman, Sam Schultz.
Hello.
What a time in the history of our universe where you can take a picture of a galaxy 13 billion miles away, and also you can have any guest host of your dreams on SciShow Tangents. Who is it? It's not actually true, but I want to know who would be your absolute thrill of the moment to be on the podcast. Has to be a living person. No Abraham Lincolns.
No ghosts on the pod. They're too scary.
Yeah. We can get them, but give me the heebie-jeebies.
Yeah.
I'm so scared of everyone I respect that I don't know.
It's worse than ghosts.
I will say that I have a fantastic idea for if we can ever get John on the podcast.
Oh, yeah? Okay.
Just a great idea.
Oh, I can see what I can do about that. Do you want me to go first?
Yeah.
Because you guys are so afraid. I think it's not impossible to get Alf. Who is?
Yeah, Alf. Yeah.
He's got a literal, like a totally different view on science, being from another planet.
He's from Melmac.
He's from Melmac, and I think it has just a wildly different sort of outlook on the world. But I feel like he'd be quite a classic guest host for SciShow Tangents, especially the video version.
Yeah, that would be essential. Do you know Alf's real name?
I did at one point. I think that I did a trivia about Alf once, and I knew it for that reason. But
It's the best fictional name of all time, I think. Gordon Shumway.
yeah,
I love that.
All right, so I did mine. Alf, who's yours?
Oh, shit. That's such a good answer.
So the closest I can come up with is just Taika Waititi, because I would like to have said that I would have a conversation with him. And I think he could carry...
He'd be so good at it.
He would carry the entire 30 minutes with comedy. We would not get a single joke in. And if one of us made him laugh, that would be a story we tell for the rest of our lives.
That's the best. That's better than Alf. I'm going to just slide into his DMs right now. I'm sure they're open to me.
No, I'd throw up if a famous person was on our show. Don't do this to me.
You don't want us to succeed, Sam?
No.
He seems like a down-to-earth famous person, too. He naps all the time.
Know, he doesn't have that many more followers on Twitter than me.
Oh, yeah, you're famous. I forgot about that.
He's Alf follows him.
Really?
Oh,
Yeah.
that's it. We get him on, and then we get Alf on. It's a 1-2 kind of deal.
All right. Every week here on Tangents, we get together to try to one-up, amaze, and delight each other with some science facts while also trying to stay on topic and failing. Our panelists are playing for glory and for Hank Bucks, which I will be awarding as we play. At the end of the episode, one of these beeple is going to be crowned the winner. And yes, I did call you beeple. We've come to the end of Kids Month, a month and some change of celebrating the childlike wonder of science. We hope you enjoyed, and we hope that you will also enjoy SciShow Kids, our YouTube channel for early elementary learners. It's hosted by Jessie Knutson-Castaneda, who you may know from her channel Animal Wonders, and Anthony Brown and Squeaks the Robot Rat. Now, as always, we're going to introduce this week's topic with the traditional science poem this week from Sam.
On TV, spaceships look like fun in games, like when flown by George Jetson or his wife, Jane. They can zip all around the Milky Way in ships with fake gravity and advanced sick bays. But in real life, when you're on a spaceship, you put your ass on a vacuum just to take a shit, and artificial gravity isn't real. You float around when you sleep and eat goo every meal. You and 4 people all trapped in a can, and you can't take a shower till you get back to land. And though there's universal splendor wherever you look, there probably aren't even video games. I bet you have to read books. So astronauts are cool, but spaceships are no fun. Get back to me when they have warp drives and sweet laser guns.
That's great. Our topic for the day is spaceships. I don't want my spaceship to have laser guns because that means that somebody else's spaceship has laser guns.
You're shooting asteroids with it. Come on.
It's just
Purely
it's just to clear up
asteroids.
the asteroids.
Yeah.
Okay. All right. Yeah, you're right. Spaceships have the biggest gap between what it's actually like in real life and what it should be like based on what the name is.
Yes.
It's like a submarine, but worse.
Oh, a submarine's pretty bad too, but yeah. You're not floating around in a submarine. Hopefully. If you are, you're in big trouble. But
Oh my God. So, Sari, what is a spaceship?
Well, if you try to Google spaceship or you look in any academic paper, the stuffy scientists, no one writes about spaceships. It's solidly in the world of fiction.
Okay, so there are no spaceships, is what I'm hearing.
So they don't exist at the end. No.
All these terrible spaceships we have now, those don't count.
Those don't count because no one ever calls them a spaceship. They call them spacecraft instead.
Oh.
And I like started speculating as to why, but it seems like this is the rabbit hole that I fell down instead of the normal etymology, because spaceship is pretty standard. Like it's space as in outer space and ship as in a boat. And then you squish them together and then you got a spaceship. But the earliest known use of the word was from 1879, a passage in the book, I think, Progress and Poverty by Henry George, who was talking about spaceship Earth. So the Earth as a spaceship, which Disney World has really capitalized on, but the idea that we are hurtling through space and have all our necessities, and we are the crew.
If this is a spaceship, then this is a great spaceship.
Yes.
What an amazing spaceship. It doesn't even need a lid. It's open air.
It's like a space train, more like, though. It don't get to go anywhere. It just
True, it's
kind of
stuck on the
stays in the
rails.
same place.
It's true.
Yeah.
So we got a space train there.
Space Train Earth. We got to change the name.
And then a writer named J.J. Astor wrote a novel called A Journey in Other Worlds, published in 1894. And that's when the word spaceship is generally credited to, in the sense of a spacecraft that is piloted in outer space, as opposed to like something that was fired out of a cannon or autonomous in some way, because science fiction writers have dreamed up all kinds of scenarios. So that's where the word came from. And as far as I can tell, this is where it gets into Sari speculation. There's a lot of nautical stuff going on. There's been a lot of nautical stuff for a while in like a big ship, a big tankard. You travel across the ocean. And so it made sense to science fiction writers and in communicating these speculative fictions to draw comparisons between space and the sea, because they're both vast, they're both scary. You go off into the unknown, and you can kind of visualize it with similar mechanisms. Like you have little ports, and then you go to and from various destinations, and in between there's this vastness that you have to navigate. And planes really weren't a thing until the 1900s. So when we started dreaming of space travel, we didn't have space plane. Couldn't come up with that word. We had the word ship around, so it was easy. Just.
So you're telling me that we were thinking about spaceships before we had planes?
I think so. I don't know
That's
about
nuts.
flying machines. It was before the Wright brothers. We had earlier planes, but we had the idea of a spaceship before.
Sure.
We had
Just
regular
like bullets
air.
getting shot into the moon's eye and stuff. What I'm getting, though, is the vague sense that we've never made a spaceship. Just because our spaceships aren't quite cool enough.
No, I don't think we've ever made a spaceship. And the thing that is closest to it is a crewed spacecraft. So any spacecraft, which is like a thing that we send into
the space shuttle.
The shuttle got pretty
Yeah,
close.
the shuttle.
Yeah.
And
It
or
looks
like a
right.
space station. There are people inside
Yeah,
and it's floating around. It's not really being piloted, but it's moving in space and it has a lot of accoutrement.
One of the things that our spacecraft don't have is the ability to like go somewhere at will.
Yeah.
You know?
Yeah.
Like that's where the space shuttle kind of seems like a spaceship, because it could go to the space station, or it could go to Hubble, or it could go various places in a relatively low Earth orbit. That almost seems like a spaceship to me. And it can go back down and land on land, which is cool.
The space shuttle didn't just orbit. It could jet around.
No, it just went up to the orbit that it wanted to go to, but it could go to a variety of different orbits.
Okay.
Well, it's easier to define what our topic is when it doesn't quite exist yet. So I feel like the topic is well covered, and now we're gonna play a game. You guys, are you ready for a game?
Yes.
Yeah.
We're gonna play that game called Scientific Definition. Do you remember that game?
So
yeah.
you say words and we tell you what they mean as
We
best
just
we
guess.
can.
So it's taken a lot of ingenious engineering and smart people to figure out how to create giant vehicles that can launch into space and do stuff. And it's also taken a lot of parts. So today, we're going to play Scientific Definition Spaceships Edition. I'm going to give you the name of a spaceship part, and it is up to you to guess what that part does. Whoever comes up with the closest to the actual definition wins a point. Are you ready to play?
Yes.
You're going to have to stretch your brain muscles to tell me what is a yo-yo weight.
Oh, man. I've played a lot of Space Team, but that has prepared me none to do,
I
do
love
this.
Space Team.
So these are things that are real?
This is a real thing. A yo-yo weight is a real thing.
I think yo-yo weight probably has something to do with getting the satellite out of the back of the space shuttle. You know, when the thing opens up and the thing goes out of it?
Yep.
Somewhere in there is where it's happening with the
There's a
yo-yo
yo-yo,
weight.
yeah. Some yo it's some kind of counterbalance for lifting a thing out of a thing.
Exactly.
Sounds good.
Yeah, I don't know if you need a counterbalance in space, I guess.
Sure you do.
You do? Okay.
There's mass up there.
Okay.
I'm going to do the opposite of that, but maybe not opposite enough for you to clearly decide a winner. A yo-yo weight is something that it's like a grappling hook in space where if you want to go somewhere, you kind of throw your yo-yo and then drag yourself along behind it.
Oh, that's cool.
So you throw out your yo-yo and then you drag yourself along the yo-yo?
Is it
Yeah.
like a bladed yo-yo? A magnetic yo-yo?
I think you can hook the yo-yo onto things, or I don't know how physics works enough to really visualize it, but you're using the yo-yo's weight to heft yourself around.
And when you say yourself, who is on the other end of the yo-yo?
You must be close.
Because you guys are both a little close, so I'm getting granular.
I think it's someone who's doing extra vehicular, an EVA.
So a human being.
A human being, yes, not an object.
All right. Well, then it's going to Sam.
Ah.
Because no human being is involved in yo-yo weights, so it's a part of a mechanism. It's called a Yoyo Dspin that helps stop the spin of satellites and spacecraft after they launch. So when they launch, they might be launched with something called spin stabilization, which keeps them spinning around their axis. It reduces the effects of wind or drag or other variables that might apply torque to the spacecraft and get it off course. So this acts like a gyroscope, and it works pretty well, but it also means that the spacecraft keeps spinning after launch. It does nothing to slow it down or stop it from spinning, and that might mess instruments inside up. So to slow the spin down, the Yoyo Dspin is deployed. The idea is sort of like the opposite of a figure skater who brings in their arms to keep spinning faster. Instead, the Yoyo Dspin extends weights out on cords and then releases them, increasing the moment of inertia and slowing the spin until it's really easy for it to slow it the rest of the way. And yes, that means that there are yo-yo weights just floating up there in space.
Oh, they let go of them. They let go.
Yeah, so like it goes out until it like slows down, and then it's like pop, and then it stays slow.
We have no respect for our orbit at all. Just full of junk up there.
It all falls back eventually. There's a lot of space up there.
I guess so.
We have
But it is
very
a worry.
little respect for our Earth, too. Have you
That's
seen someone
true.
finish a sandwich and just go to the piece of paper? So
All right. So our second part on a spaceship that that is real, and you don't know what it does, is the rapid scat.
Oh, God, I've heard of this one.
Have you?
Yeah.
rapid scat. I bet it's something to do with like a detection. So it's a implement that's on the like tool control module of whatever a spacecraft is.
Is that a thing?
Yeah,
I don't know.
TCM.
Oh, okay.
Yeah, you know. If I use more fancy words, then it sounds more real.
Yeah.
But it's like the less cool equivalent of the little green radar that goes bloop, bloop, bloop. If an asteroid's coming towards you, it just like rapidly scans around you and tells you if there's anything of note.
Okay.
Or like the general status of your system.
I think it's some kind of little propulsion system that makes tiny adjustments to push you around just a little bit.
That one's going to Sari because it is in fact a detection system, kind of, but does not do what you said it did. But it's a scatterometer which is apparently a thing, on board the International Space Station. It was launched in 2014. Its job was, it's not there anymore, to measure ocean winds, which made it very important to a lot of agencies as a way to keep track of weather patterns and detect big storms. The RapidScat was actually created to replace NASA's QuickSat Earth satellite, which had stopped working in 2009. JPL needed to find a way to quickly and cheaply replace it, so they found a way to reuse hardware that had been used to test the QuickSat to assemble the RapidScat and send it to the ISS. The RapidScat ran for 2 years before it was decommissioned.
What happened to it? Just got tired?
I think they found they launched a real replacement for the QuickSat.
Okay.
Yeah. They launched better scat.
Thanks for not guessing a poop thing, you guys. The next one we have is a Whipple Bumper.
No.
Oh,
I'm not kidding. It's a real thing, the Whipple Bumper.
Whipple Bumper.
Oh.
Can you use it in a sentence?
Yeah, so they used the Whipple Bumper on the space station.
Okay.
Okay, so when you're on stuff like that, there's got to be like some kind of arm or something that's moving around. And when you're spacewalking, if that bumps into you, you're in trouble. That's where the Whipple Bumper comes in.
So you're the Whipple.
Yeah.
And if you get
The
bumped.
Whipple Bumper protects you from getting bumped.
I suppose it's some kind of skirt or some kind of something with air inside of it to prevent damage to spacewalkers
from being bumped.
from being bumped, which is
Yeah.
kind of the only thing that can happen to you in space, really, isn't it? Just bumped by various things in variously serious
that's-
ways.
Life is just a series of bumps.
Yeah, that's kind of all that can happen to you, period, huh?
Yeah, even here on Earth, we're just bumping
Yeah.
Yeah.
into the floor.
That's a
into our
great
couch.
Will Smith song.
I'm bumping
We're
in the
here
floor.
on Earth. We're just
We're just
bumping.
bumping.
Yes. Sari.
I think a Whipple Bumper is like when one space station module and another space station module love each other very much, and then they're like
Yeah.
want to become a bigger space station, and then they Whipple bump together, and they
Okay.
interlock, and become one larger space station.
You guys got sharp brains today. The Whipple Bumper is neither of those things, but it's closer to what Sam said. It's a Whipple Bumper, also known as a Whipple Shield, is an aluminum shield around a spacecraft that breaks up approaching debris to distribute its impacts and lessen the damage to the craft. It gets its name from the inventor of it, Fred Whipple, who
fun.
designed this shield in the 1940s.
So it's like the Enterprise has its like deflector shield, but it's just some
Yeah.
piece of metal.
Yeah, it's,
Okay.
it's a particularly crafted layered aluminum thing that's really good at spreading out the impact of impacts.
Ah.
All right, we got one last thing here. It's called Sherlock.
Okay.
So it doesn't have a K on it, so you know it's an acronym.
Yes. They love
Sherlock.
to name these things roughly after what they do, I feel like.
It is the super.
Oh God, you're gonna do
Oh,
the
you're
whole
gonna
acronym?
actually-
Yeah. Heavy, exciting,
Oh.
rock, locator,
not.
or crusher.
Oh.
Well, you could have just been locator, and it's like LOC.
Oh, you're right.
Yeah.
Well, I said or crusher. It's documented, so now my shame
So,
is
yeah.
public.
So you think it both locates and crushes rocks?
Yeah, well, like
mean, why not?
hypothetically,
Yeah.
they like fist bump it and go, "You crush that, Sherlock."
There's at least a bump because
Yeah,
of how everything bumps.
Yeah, there can't not be a bump.
Yeah, there can't be a
Establish
bump.
that.
Yeah.
and so what it does is it locates rocks. It's like, oh, and then they say, "Good job, Sherlock. You
Careful,
found cool
careful.
rock."
That's like the same. Oh, it's not warning it about rocks.
No, it's like detecting so let's say it's detecting the rocky composition of asteroids or the moon. I don't know, anything nearby, rocky bodies nearby.
That's almost exactly what I was going to say. I was going to say it was like a sample analyzer, but now I can't say that. So it is it's a health monitor of some sort for humans on
Yeah.
something, on a
It's
space
Baymax.
station.
Strap it on your belly and it tells you how you're doing.
Yeah, exactly.
It says you're gonna have to go soon.
Yeah, you're eating too much goo. You got to get back to Earth.
Well, Congratulations to both of you. Sam, I don't know why you didn't go for it. I would have tried to find some way in which your Sherlocks were different, but the Sherlock indeed is a tool on the Perseverance rover, and it's tasked with searching for organic compounds, minerals, and other signs of past microbial life on Mars, and it does that with a whole bunch of cameras and spectrometers and a laser. So it bumps with light, at least, which is another kind of bumping. And it does that with its co-investigator, Watson.
Oh.
So Sherlock stands for Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals. And Watson stands for Wide-Angle Topographic Sensor for Operations and Engineering.
I was going to say, I love how they can always make it work, but
they didn't really make it work. So yeah, great work, Sari, and also Sam, but you should have just committed.
I should have
fought for it.
I wanted to, Sari needs a win.
Thank you.
Well, you came out of it exactly tied, so well done on that. Next up, we're going to take a short break, and then it'll be time for the Fact Off.
I thought of some people I want on the show. Can I just interrupt real quick?
Ready after the break.
Hit me.
I want Bill Oakley, the man who invented steamed hams from The Simpsons. Do you know what I'm talking about?
Is that a real person?
Yeah.
Like the steamed ham. He wrote
does like
the
a pretty
episode?
popular TikTok reviews of food. So
Okay.
you and him would have a lot to talk about.
I mean, Alf is also not really a real person. So.
well, Bill Oakley is literally a real person.
Okay.
I want Joel from Mystery Science Theater.
Okay, that's actually maybe doable.
Yeah.
I know people who know him.
And I want John Hodgman. I think John Hodgman would be fun.
Oh, I know people who know John Hodgman. I know John Hodgman.
I know someone who knows John Hodgman. It's you. Okay, now we can go to break.
All right, everybody, it's time to get ready for the Fact Off. Our panelists have brought science facts to present to me in an attempt to blow my mind. And after they've presented their facts, I'll judge them and award Hank Bucks to the one that I think will make the best TikTok. And to decide who goes first, I have a trivia question. One of the most important tasks of building the James Webb Space Telescope was figuring out how to actually get it into space. In the early 2000s, decades before the actual launch of the telescope, NASA settled on a launch vehicle, the Ariane 5, which belongs to the European Space Agency. They picked the Ariane 5 because they considered it to be one of the world's most reliable launch vehicles, and the only launch vehicle that met the Institute's requirements for transporting the telescope. Between 2003 and 2017, the Ariane 5 had a very impressive string of missions that launched consecutively without failure. How many missions did it launch in that time?
Oh, I have no concept of how many missions humanity does in any time.
This is a good question. I'm going to say less than one per year. That feels too expensive and fast.
But it's all of Europe, Sari.
I'm going to guess 10. A nice even 10.
I'm going to guess 25.
82.
Oh, whoa.
That's so
we go
many.
up there space a lot, huh?
Yeah. So a lot of successes, but the mission that broke the streak of success was in 2018, and they figured out that it happened because the rocket was given the wrong coordinates.
Oh, no.
So it was not really the rocket's
That's not his fault.
That sent it 20 degrees off course and caused the rocket to lose contact with ground control, and that was bad.
Human error.
But
doesn't count.
it worked so well that the JWST launch that it saved the telescope a bunch of fuel, extending its operational time from 10 years to 20 years. So that's not bad.
No.
Yeah.
As long as it's fairly safe from those micrometeoroids, which are now my biggest fear.
Oh, yeah. What happened? It got hit by one.
It got hit by they knew it was going to get hit by a little, technically micrometeoroid, because micrometeorites only happen when they hit the planet, I guess.
Yeah.
When they hit our atmosphere. Anyway, there's dust in space and it's moving real fast. And they expected it to happen, but it got hit by a piece that was bigger than they expected, which is concerning because if it's going to get hit by pieces that big, like basically if it took 6 months before that thing hit it, if this happens every 6 months, it could, over the course of the mission, significantly degrade the ability of the telescope to get, the same quality of science that we're getting right now, though it would still be better than anything that we have by a wide, wide margin.
Shoot.
So.
Needs a Whipple Bumper, huh?
Well, you can't really put a Whipple Bumper on your giant beryllium gold-plated mirror.
Okay.
Because it needs to see.
I guess so.
But yeah, exactly. If only we could have built a Star Trek-style Whipple Bumper made out of...
light or whatever it's made out of. I have no idea.
Yeah, deflection feelings.
Yeah.
Yeah.
All right. So, well, that means that Sam gets to decide who goes first.
I'm going to go first. I had an off week, so I'm just going to get out of the way.
I'm sorry.
When humans launch things into space, we basically make a big old mess. From satellites to manned spacecrafts, launches leave different rocket stages in orbit, and even the craft and satellites themselves can become space junk eventually. And in Earth's orbit, this is getting to be an issue. According to NASA, there are about 23,000 bits of man-made space junk orbiting Earth, and each of those things is a potential hazard to other things that are launching into space and to people, because something might squish them someday or something like that. There is, of course, another heavenly body that we sent people and other stuff to, the moon, and junk accumulates in its orbit too. Right now, there's estimated to be a couple dozen bits of debris orbiting it, but the moon, he's just a little guy. And with several governmental and private entities interested in getting back to the moon in the near future, an estimated 50 missions in the next decade, the concern is that there's going to be just a big dangerous mess up there in pretty short order. And on top of that, the moon is so bright that it's long been considered impossible to track things that orbit it, because you just look at it, it's a big orb of light. Impossible that is until 2020, when a scientist named Vishnu Reddy was observing China's Chang'e 5 lunar probe using a regular backyard telescope, and discovered sort of accidentally that he could see a slight flicker at the edge of the moon as the probe orbited. And he figured out, because of these flickers, how to track it within 100 miles just from his own observations with his backyard telescope. Then he gathered more data and brought it to his colleague Roberto Ferfaro to develop an algorithm that could accurately forecast the orbit of the satellite. And this got the attention of the Air Force, who gave the team a $7.5 million grant to develop what will be, in essence, an air traffic control AI that can track all of the crap that's orbiting the moon and help map out safe routes so manned ships aren't getting hit by stuff. So right now, the team is like cataloging all the junk up there before they start writing the AI. And that leads me to my real fact, because this was all just a preamble. The facility these researchers are working out of is none other than Biosphere 2. The program is run by the University of Arizona, which I guess owns Biosphere 2. And Biosphere 2 apparently has an observatory, or like a array of sensors, called the Space Domain Awareness Observatory, which I looked up, and all I could find about it was this article, basically. So wacky old Biosphere 2 could become the space air traffic control tower of the future, and I think they should invite us there to look at it and do an episode of Tangents. So doctors Ferfaro and Reddy, if you're listening, please, I want a podcast from Biosphere 2.
Gotta get in and play with our microphones.
Yeah.
That sounds a little humid, but very fun.
I think it would be great. We could sit in sit in the desert room. We could sit in there and do it.
We could sit anywhere, as long as I get to act out scenes from Biodome.
Yeah, I'll watch it and we can do it together.
Oh my god! Oh, and then we could do a commentary for our
movie.
Patreon patrons.
We could do a commentary for Biodome and Biosphere 2. That's the best idea I've ever heard.
It seems achievable. The biggest problem is getting Sari on a plane.
I can go to Arizona, please, for this, for something this important. I'm there immediately.
It's good to know.
We'll replace her with John Hodgman for that episode.
No!
Me, you, and John Hodgman in Biosphere 2 doing a commentary of Biodome.
That's very weird. I would think that people would just know where their satellites are. They had to look.
I don't think anybody cared to keep tabs on them. So it's just it's like stuff left over from all of the missions that have landed and stuff like that. I like that thing hit the moon recently, and everybody was like, "What the heck?
What the was that?"
Because nobody's like keeping track of any of it.
Yeah. It is weird that we had like a big rocket booster fall on the moon, and everyone was like, "Oh yeah, I guess that." I don't know. It was some thing that was up there. Okay, Sari, what do you got?
Like Sam mentioned in his poem, an important part of all kinds of sci-fi spaceships is artificial gravity. So instead of floating around like astronauts in the ISS, our imagined fictional space travelers are walking around with their feet on the floor of the ship, also making film sets a lot more convenient for everybody. But real-life engineers are also interested in artificial gravity to possibly combat some health effects from sticking human bodies in microgravity environments over long periods of time, like, say, a journey to Mars. So there have been a handful of hypotheses over time, and one absolutely wild experiment on September 14th, 1966. It involved the Gemini XI spacecraft, which had a crew of 2, and the uncrewed Agena target vehicle, which was a modified rocket stage that had been used in a variety of experiments like practicing docking. And the goal was to unravel a 100-foot tether between the Gemini XI and the Agena, keeping it nice and taut. Then they wanted to fire thrusters to spin the whole system, generating a center of gravity in the middle of the tether and a force that pushes outward, like those gravitron fair rides. And theoretically,
there's people in one of them?
There's people in one of them. They were firing the thrusters. And theoretically, if the capsule spun fast enough, the astronauts would be able to walk along the edge as if it was the ground and experience some artificial gravity, like in 2001: A Space Odyssey. What could go wrong? Turns out that whipping 2 objects that weigh thousands of pounds each around in a circle while they're connected by a rope is pretty chaotic. There were a couple hiccups during setup, like the tether getting stuck at 50 feet and then at 90 feet, and then the tether not pulling taut as nicely as they had hoped. Yeah. And so then they were instructed to fire the thrusters a little to pick up the slack, but then the tether started whipping around like a jump rope between the Agena and the Gemini XI capsule, which was definitely really fun, not scary at all. Even with that terrifying sight, they kept firing the thrusters and straightened out the tether until they got a comfortable 38 degree per minute rotation going through the night. And because scientists can be both smart and dumb, the folks on the ground then asked the Gemini crew to spin faster. They were like, you got it stable. Now hit the gas again.
Let's go.
And that tightened the tether and started slingshotting the astronauts around, at which point one of them yelled, "Oh, look at the slack. It's gonna jerk this thing to heck."
Oh, no. I'm glad he didn't swear.
Yeah. And somehow, those weren't his last words, and the astronauts stabilized the whole system to a speedy 55 degree per minute rotation, which doesn't seem worth the trouble, which generated a whopping 0.00015 G of artificial gravity. So very small.
So like you basically, if you put something on the ground, it might not come back up.
Yep. And that's exactly basically what they did, which was they couldn't feel it, but they placed a camera against the instrument panel of Gemini XI and let go. And then it moved parallel to the direction of the tether and hit the back wall. And they were like, well, that's our artificial gravity, I guess.
That's the last time we're going to try that.
Yeah. And then they released the tether and got a safe distance from the Agena capsule. Hooray? ? And there are a lot of hypothetical problems with spinning spaceships and practical ones if you count the chaos of this mission. And I don't think we've tried anything since. But I'm sure it is just one of plenty of other wild ideas brewing when it comes to artificial gravity that we'll experience someday, maybe.
The idea that you do that with a craft that had people in it.
Yeah.
Mm-hmm.
Like, you could do that without people in it.
Yeah, it's not like you have to have people who are like, oh, I'm feeling gravity
Maybe in
now.
1969 it was a lot easier to do with people in it because you had to have somebody to push buttons, literally, because a computer could only add. I don't know. Like because it was significantly less advanced than your phone is, of course.
Yeah.
But like, so now I feel like we should try that out. Like, we have a lot more control over things now than we did then. But still, I wouldn't want to be on one end of that tether because if anything goes wrong, what did he say? It's going
to jerk this thing to heck.
Yeah.
You don't want that
I feel like it's going to jerk that thing to heck. And when that happens, you just shoot off. Once it gets jerked to heck, if you're lucky enough to keep your vacuum seal, you just get flung off in whatever direction you happen to be going in when it broke.
Couldn't they have done it tiny with like an ant or something also? Couldn't they have put like an ant in a ping pong ball and been like, all right, dink, spin it around?
Yeah. inside the thing, just like like a hamster wheel.
Yeah.
Mm-hmm.
Yeah, it's amazing that it all went as the early space missions went as well as they did. All right, so now I have to choose between these two things. I got two excellent facts. I've got air traffic control for the moon from Biosphere 2, which could be a great place to record an episode of Tangents, or Sari, a really ridiculously dangerous but ultimately I guess successful artificial gravity experiment during Gemini. Gosh. I'm going to go with Sari.
Well,
it's just a slightly better story because the people were almost killed.
Well, okay. I feel like you have a bias, but that's okay.
What do I have a bias towards?
What's
my bias?
Towards Sari. Towards Sari bias, yeah.
Okay. Not toward like space or toward death,
weird historical missions.
No, just toward Sari specifically.
Yeah.
Okay.
Yeah. I'm okay being your fan favorite. I can be pod favorite.
Hank's favorite?
Yeah, I can be Hank's favorite. I'll be Hank's favorite podcaster.
And that means it's time to ask the Science Couch. We've got one from Mohammed ML Eng who asks, how does a gyroscope help compensate for the rotation of tape reels, tools, etc.? It's just a spinning top, right? It's just a spinning top, right? All I know is if you're holding a fidget spinner and you move it, you can feel the force of the spin, whatever this force is. And so a gyroscope wants to stay in one position. And if you push on it, then it will push back. And you can use that push back to change the orientation of stuff in space. Am I right?
Yeah, that's the bet. It took me probably an hour of research to get to that point where I could explain it that simply. I was like, I gotta digest all this physics. I gotta make sure, watch these videos. Incomprehensible. I'm gonna say it good, and then you just said it good.
That's why I picked this question. Remember, I said Hank's gonna know the answer. I
know, but I was prepared to not embarrass myself. But.
Well, I can tell you, I don't really understand the physics of it. It is only because of fidget spinners that I have any intuitive understanding of how a gyroscope works. Without that, I wouldn't. It's real weird that momentum creates a force. Because I guess it's because it's spinning away and it has inertia in that direction. And when you change the direction, you are changing the inertia. You're pushing against you are forcing it to go against where its inertia wants to go. And I've also seen astronauts in space do stuff with gyroscopes where they put it there, and instead of doing what anything else would do, which is just float around, it's just
yeah.
Oh, weird.
I think in answer to the end part of this question, which is it's just a spinning top, right? So the gyroscopes you see are not just a top. A spinning top is either governed by or has a gyroscopic effect on it, which is that once it's spinning fast enough, it wants to remain spinning around that axis, like Hank was saying. But a gyroscope, like the ones that you see in the space videos or the ones that are little desk toys, are a spinning wheel that are mounted onto those rings around it called gimbals, so that as forces are exerted upon it to switch how the gyroscope would be spinning, it remains around the same axis, and instead the gimbals spin around it. It exerts a counter force onto the gimbals, and then those move around it. And so that is how the gyroscope, the flat surface of the gyroscope, remains spinning on the same plane. And it can be readjusted by a human poking it, but as space is moving around it, it will stay moving, and the gimbals are going to be the things that switch, because the spin, that angular momentum, is what is maintaining the orientation of it.
And this is something we're using a lot in space?
Oh, yes.
Yeah.
Okay.
So we use it in a lot of different technologies. They're called collectively inertial navigation systems. And they use a combination of gyroscopes and accelerometers to get information about which way a thing is pointing and how fast it's moving in that direction to make little corrections.
And it's how, like, if a satellite wants to change orientation in space, it doesn't have to use reaction mass. It doesn't have to, like, throw stuff out to change its orientation. It can use the gyroscopes to actually alter the way it's pointing. It can't, like, move in a direction, but it can change the direction it's facing.
Whoa, I never even thought about how they would do that.
Thanks to everybody for your hard work. We are podcast hosts. And
I'd just like to see him try to do our job, though. Come on.
That's right. Well, if you want to ask the Science Couch your questions, you can follow us on Twitter at SciShow Tangents. We tweet out topics for upcoming episodes every week and then look for questions. Or you can join the SciShow Tangents Patreon and ask us on our Discord. Thank you to at Mucolepticon, Napoleon on Discord, and everybody else who asked us your questions for this episode. If you like this show and you want to help us out, super easy to do that. First, you can go to patreon.com/SciShowTangents to become a patron and get access to things like our newsletter and our bonus episodes. And second, you can leave us a review wherever you listen. That's very helpful and helps us know what you like about the show. And finally, if you want to show your love for SciShow Tangents, just
tell people about us.
Thank you for joining us. I've been Hank Green.
I've been Sari Riley.
And I've been Sam Schultz.
SciShow Tangents is created by all of us and produced by Sam Schultz. Our editor is Seth Glicksman. Our story editor is Alex Billow. Our social media organizer is Julia Buzz Bezio. Our editorial assistant is Deboki Chakravarti. Our sound design is by Joseph Tunamedish. Our executive producers are Caitlin Hoffmeister and me, Hank Green. And of course, we couldn't make any of this without our patrons on Patreon. Thank you. And remember, the mind is not a vessel to be filled, but a fire to be lighted.
But one more thing. The first U.S. spaceflight program was Project Mercury, so NASA was figuring out a lot of stuff from scratch. And of course, one concern was keeping astronauts as comfy as possible while they experienced the extreme 3G or so force during launch. So, some of the astronauts that were selected for Project Mercury over the years had a personalized butt mold made, so engineers could design spaceship seats that would perfectly cradle their butts.
That's nice. Why didn't all of them, though? Some of them just don't care about their butts?
They were like, turns out it doesn't matter that much.
Just stick a big pillow down there, and it'll be uncomfortable no matter what you do.
Yeah. Get a memory foam pillow.